Okay, now we will go through the exemplar problems in class 12 chemistry chapter 4 chemical kinetics. Okay, see, I will show you some general information. This rate equation k equal to a into e power minus e, this is the Arrhenius equation. A is the Arrhenius factor, EA is the activation energy, R is the gas constant, T is the temperature. So when we increase, suppose when you decrease the activation energy, then the rate constant will increase. Okay, this is a negative sign. So EA decreases means K will increase. Similarly, when you increase the T is in the denominator here, so the K will increase. Okay, 1 by T will decrease because of the negative sign. So when activation energy decreases, K increases, temperature increases, K increases. Okay, see here in this curve, this reaction coordinate versus potential energy in a general reaction. Okay, this is the EF is the forward activation energy. This from here to here. This is the forward activation energy, and this level to this level is the backward activation energy. And the difference between these two energies delta H. Okay, change in enthalpy. Okay, so be backward. This is the activated complex. So when the reaction is exothermic, that means delta H is less than 0. That is, energy of the product is less than the energy of the reactants. So here energy is released. So okay, the energy is satisfied. Energy of the product is less than the energy of the reactant. Energy is released. In the endothermic, then delta H is greater than 0. That means the product's energy is greater than the reactant energy. Energy is absorbed in this reaction. Uh, this is called a Maxwell-Boltzmann in distribution curve. So this is kinetic energy versus the fraction of molecules. Ne by Nt, that is the number of molecules at a particular energy level is Ne. Nt is the total number of molecules. So the fraction of molecules versus kinetic energy at this temperature T, here higher temperature T plus 10. So in both the temperatures, the area under this curve is same. Okay, the area under this curve, area under this curve, and the second curve, both are same only. See here, this peak is here, and this peak is less than, but here it is more here. So the area under the curve is same. Okay, when you increase the temperature, the peak shifts to the right side. See here, lower temperature, the peak is here at this energy level. This is kinetic energy and the number of molecules. Okay, lower temperature peak is here, higher temperature peak is here, that is shifting right. So the energy is increasing here. That is, here energy is more than the energy here, because x-axis is energy, but the most probable that kinetic energy shifts right side. Okay, here this is more number of molecule at lower temperature having this energy level. Here more number of this more energy here. Okay, area under the curve is same. At temperature T plus, then the fraction of molecule, this is the fraction of molecules, this is the activation energy. Fraction of molecules after this activation energy increases when temperature increases. See this curve and this curve area is more here than this curve. So this fraction of molecules gets doubled. From this area, this is getting doubled, and so the rate of the reaction. Okay, at higher temperature, the maximum curve shifts on the right side of the shift to the right side. Okay, more molecules greater than the this is more number of molecules, because this is the number of molecules. You see this curve is slightly higher than this curve. Ne is the molecules at energy E, Nt is the total number of molecules. Okay, so here important thing is the both curves having same area, because the total number of molecules are same. Only when you increase the temperature, this peak shifts right side, and more fraction number of molecules are having more energy than the activation energy. Now, if you use a catalyst in a reaction, this top curve is without catalyst, and this dotted line is with catalyst. Reaction coordinate is the potential energy. So when you use catalyst, so this activation energy is getting reduced. Okay, so there is alternate path of the reaction, and the activation energy is getting reduced. So the catalyst lowers the activation energy of the reaction. Okay, that is faster rate, and it does not change the delta G, that is Gibbs constant. It does not change the delta H also. Equilibrium constant also is not changing. Only thing is lowers the activation energy. Catalyst provides alternate path for the reaction. Okay, this is the alternate path reaction. This is the normal reaction without catalyst, with catalyst, the product and reactants. See, when you have a reaction, the rate of disappearance of the reactants is equal to rate of appearance of the product. Okay, reactant constant decreasing, then product concentration is increasing. So you take this reaction. What is stoichiometric coefficient means? This is general form of the reaction. This A, B, C, D, they are stoichiometric coefficients. Okay, here in this reaction 2 is the stoichiometric coefficient. Okay, how do you find the rate of the reaction? This is based on the concentration of the power of the concentration of the reactants. Okay, here if you write A equal to K into concentration of A X, concentration of B Y, that means X plus Y is the overall rate of the reaction power. Okay, and X is the rate of the reaction with respect to A, Y is the rate of the reaction with respect to B. Okay, in zero order reaction, this rate constant is equal to the rate of the reaction, because this concentration of the reactant power 0 is 1. Okay, anything power 0 is 1, so the rate constant is equal to rate of the reaction. So that means here it is directly proportional to the concentration of the. So this see this T off means this is off life time. Okay, T off means, so the off life time of the zero order reaction is directly proportional to the concentration of the reactants. Okay, but in the first order reaction, Tf is a constant and is independent of the reaction concentration. This is for the first order, this is for the zero order. Tf for the zero order, and this for the first order is independent of the concentration of the reactions. Okay, the role of a catalyst is to change. I already showed you that a catalyst does not change the Gibbs energy of the reaction, does not change the enthalpy, does not change the equilibrium. It changes the activation energy of the reaction. That is low, reduces the activation energy of the reaction. To only lower the activation energy of the reaction, it does not change the delta G and delta H or equilibrium constant. In the presence of the catalyst, the heat evolved or absorbed during the reaction. It will not change because this delta H is not changing. Okay, enthalpy there will be no change, so remains unchanged. Activation energy of a chemical reaction can be determined. So this you have to take the rate constant of the two different temperatures. Okay, 21. So here see they are given the rate constant at two different temperatures, and from that they are calculating the activation energy. So you can go through this example. So that's how you compute the activation energy. From the figure 4.1, here the product is having higher energy than the reactants. Whenever you have higher energy, then it is unstable. Activation energy of the forward reaction is okay. This is the activation energy of the forward reaction. Okay, that is correct. Product is less stable than the reactant. Correct, because the reactants having lower energy than the product. So the more energy means unstable. So the product is less stable than the reactant. Okay, this is correct. Activation energy of the forward reaction is this is okay, but product is more. This is wrong. Okay, this is a red release. This is wrong. That is why this is wrong. Activation of the both forward and backward. Okay, only forward. This is the forward activation energy only, not the backward is only this. So that is why this red line is wrong. Activation energy of the forward, the product is more. So this is wrong. Product is less stable than the reaction because the product is having more energy. So this is red underlined is wrong. Consider the first order gas phase decomposition. Okay, the initial pressure of the system before decomposition of the air was this one. After this the presence of the system is increased by x unit. Okay, this is given in the book 15. Okay, this is the equation. According to the Arrhenius equation, the rate constant, okay, this is the one. Which of the following represents the graph of the K? See, they are asking graph of K versus 1 by T, not T. See, 1 by T they are asking. When you increase 1 by T, then this negative value will increase. The negative value increase, rate constant will decrease. Okay. So, when increase 1 by T, the negative value is increase. That means rate constant is decreasing. So this rate constant decrease as we increase 1 by T. So 1 by T, that is important, not T. Consider this argument given below and mark the correct option. Okay, this is the, as I said, when you increase the rate constant increases exponentially with a decrease in activation energy. EA, when you decrease the EA because of this negative sign, when you decrease, that means value increases. So the rate constant increases in decreasing activation energy and increasing the temperature. Temperature is in the denominator. Okay, so this is one is the correct. Graph of the volume of the hydrogen released versus time for relation between the, okay, on the basis of this mark the correct option. This average rate is the difference in volume divided by difference in this time. Okay, this one is the correct. Okay, see V3 from 0 to V3, this is the volume change. Here V3 is 40. Okay, 0 to 40. So the difference in this and the difference in volume. But here if you see V3 minus V2, V3 is 40 only, but V2 here is V3 minus V2. V3 40 um, average rate up to 40 seconds they are asking. Okay, up to 40 seconds, up to 40 seconds they are asking. So it means up to 40 seconds means 0 to 40, not this. So up to 40 means from 0 to 40 you have to take, not the difference. Which of the following is not correct about the order of the reaction? The order of reaction can be a fractional number. Okay, order of the reaction can be, because the power of the concentration can be a fraction. Okay, they are asking which is not correct. Okay, this one is the correct. Order of the reaction is okay, this is also correct. The order of the reaction is always, no, this is wrong. Okay, this is wrong. The order of the reaction is sum of the powers of the, okay, this is correct. So now 7. See, thus the rate law in the expression in which the reaction is given in terms of molar concentration. Okay, this is correct. Which may or may not be same as the stoichiometric coefficient. This is important. Okay, which may or may not. So here they are given the order of the is equal to the sum of. Okay, this is it may or may not. So this is incorrect. Consider the which of the following does not show the instantaneous rate. Okay, we have to see instantaneous rate. So here difference in volume. So V4 minus V2, 50 minus 30 they are taking V4 minus V2, V4 minus V2. So they should be here. They are asking which is does not show the instantaneous rate of the reaction at 40th second. Okay, they are asking the 40th second. So this here they are asking, not at this 50th second. Which of the following statement is correct? The rate of the reaction decreases the passage of, okay, reactants as the time moves forward. The concentration of the reactant decreases and the rate of the reaction also decreases. So this one is correct. The rate of the reaction is same at, no, this is incorrect. Rate of the reaction independent, no, this is also incorrect. Rate of the reaction depend on the temperature. The rate of the reaction decreases with increase in the concentration of the reaction. No, this is wrong. So which of the following represents the correct rate of the reaction in the given flow? For this reaction, see, when you write the rate of the reaction for this, okay, divide by the stoichiometric coefficient, this will be this. If you multiply 5, then this 5 will cancel, this side 5 by 6 will come. So this is the correct answer. Okay, 5 by 6. Okay, multiply by 5. See, for this they are given the how we have to write the rate of the reaction, because the 2 they are divided by 2. Rate of the appearance of the product divided by the respective stoichiometric coefficients. Which of the following graph represents the exothermic? Okay, energy is released here, that is product energy is lower than the reactant energy. Product energy is here, this is the energy, the product energy lower than the reactant energy, so the energy released in the exothermic one only. The rate law for the reaction is given like this. Okay, that means B power 1 A power 1, the concentration of the B is doubled. Concentration of the B is doubled, keeping the concentration of the A is constant. The value of the rate constant, because is power 1, it will be doubled. Doubled, B doubled means 2 and power already 1. So the 2 power 1 is 2. That will rate will be doubled. So here they are given how you determine the rate constant. Okay, keeping one of the reactant concentration is same and increasing other. See here, in this step they kept this concentration of the B constant and they increased this concentration of this. Okay, then how many times it increases? In this case, how many times it increases? Based on that, they are computing the rate constant. Which of the following statement is incorrect about the collision theory of the chemical? It is incorrect, they are asking. Okay, considers reacting molecules or atom to odd spheres and ignore the structural features. That is correct. The number of effective collision determine the rate of the reaction. That is also correct. Collision of the atoms molecules possessing a sufficient threshold energy, that is activation energy, results into the product formation. Okay, so this is incorrect because this we are missing the orientation here. Orientation also is required, and the molecule should collide with sufficient. This is correct. So it is 23. With proper orientation they are given. Okay, with the proper orientation, that is missing on that statement. First order reaction is 50% complete. This is T of they are given for the first order reaction. So as I already showed you, that is independent of the concentration of the reaction. How much time it will take for the 100 content completion? See, 50%. Okay, 60. So this is T of they are given 50, then 50% to 25% also the same time it will take. 25% to 12.5%, so 100% will never reach in the reaction. Okay, that is why they are giving infinite. Okay, this is how it will keep on 12.5 again 6.2, like that will keep on going on. That is why infinite. Okay. See the given. Okay, see the how many times just get 99.9%, 10 times the first half. Wow, that this much time it takes. So you can go through this exam. That is not 100%, it is 99.9. Okay, compounds A and B react the following in the chemical reaction. Okay, so now they are changing the concentration of reaction and finding the order, as I already shown you. 17. See, first initial concentration both 0.30, then rate is this, then they are increasing the concentration of B, keeping the concentration of A constant, then rate increase by 4 times. Okay, 4 times it increase. So but we are doubling the concentration but increase. So doubling the concentration 4 times means this will be 2. Okay, 2 power 2 only it will be 4. So this is 2. Now they are doubling the A, keeping B constant, and only double. Okay, they are doubling A. 2 power, that means 2 power 1 only 2. This is 2 times only increasing by doubling the concentration. Okay, the 2 power 1 only will be 2. So now B power 2, A power 1. This is how we find the rate. Okay, this is the one. B power 2, A power 1. A power 1 is A. Which of the following statement is not correct for the catalyst? They are asking not correct. It alters the delta G of the reaction. No, this is not correct. It doesn't change the delta G, delta H, equilibrium constant is not changed. Only the activation energy is changing. It catalyzes a forward backward reaction to the same action. This is correct. It is a substance that does not change the equilibrium. That is correct. Produces the alternate path. Okay, that is also correct. The value of the rate constant of the pseudo first order reaction depends on the concentration percent in excess. Okay, pseudo first order. See here the water is taken as excess. Okay, here. So this is called pseudo first order. As though this is not participating, this concentration will be negligible when you take XX. Consider the reaction A equilibrium B. The concentration of the both reaction the products are exponentially with the time. Which of the following curve? Okay, this reactant decreases, product increases. Okay, with the same thing. Okay, same rate. Okay, this is the concentration of the reactant that decreases with the time. This is the product concentration, it is increases the time. Okay, if you look at this slope, almost same. Okay, multiple choice questions. Rate law cannot be determined from the balanced chemical reaction if the reverse reaction is involved. Okay, it is a sequence of the elementary reaction. We cannot determine the rate of the reaction. Cannot be determined from the balanced chemical reaction. Okay, any of the reactants is in excess. Which of the following statements are applicable to a balanced chemical equation of the elementary reaction? For elementary reaction, order is same as molecularity. Okay, this is 24. Molecularity can this is also correct. 24. Molecularity and the order of the elementary reaction are same here. In any unimolecular reaction, only one reacting species is involved in the rate determining step. The order and molecule of the slowest step, this is equal to 1. Okay, this for the unimolecular slowest step. Slowest step, this is the rate determining step. Okay. The number of reacting species, okay, elementary reaction which must follow simultaneously, the order being taken in the chemical reaction. Unimolecular reaction and reacting species is involved, okay. The order and molecule of the slowest step, okay, that is correct. For a complex reaction, the order of the overall reaction is same as the molecular or slowest step, that is a rate determining step. Molecular or the slowest step is never zero and non-integer. That is correct. The overall rate of the reaction is controlled by the slowest steps of the reaction and the rate determining step. So based on that, they given the order of the reaction is okay. It can be 0 or even, but molecularity cannot be 0, non-integer. For a complex reaction, the order is given by the slowest step and the molecule of the slow is same as the order of the overall reaction. At high pressure, the following reaction is a 0 order. Rate of the reaction is a rate constant. Okay, 0 order means rate of the reaction is called rate constant. I already shown you. The rate of the decomposition of ammonia will remain constant until the ammonia disappears completely. Further increase in pressure will change the rate of the reaction. During the decomposition of activated complex, energy is released, always released. Okay, energy is released to form products, that is decomposition. This is energy release is different from the exothermic endothermic. Okay, this only says energy is released, does not say whether product energy is greater than the reactant energy or product energy less than the reactant energy. Energy is released, it says. Okay, that is delta H different from this. Reactant may be formed. According to the Maxwell-Boltzmann distribution of energy, the fraction of molecules with the most probable kinetic energy decreases at higher temperature. Okay, because at a higher temperature the curve shifts right side, but the fraction of molecules with most probable energy is decreases. The peak decreases. Okay, curve only shifts right side, peak decreases. That is what it says. See here, at higher temperature this peak decreases, that is what it is saying. So peak decreases means fraction of molecules here in this peak decreases here as compared to the lower, but it shifts right side, the curve shifts right side, and this molecule here is increases. Okay, this is increasing. See here, this fraction of molecules above this activation energy is increases, and this is lower temperature, this is higher temperature, and this is the number of molecules. So what it is saying, the fraction of molecules with the most probable kinetic energy. Most probable means that is the peak. This peak here decreases at higher temperature, and this peak is more at the lower temperature. Okay, this is increase means after the activation energy. Most probable increases with the probable kinetic energy increases at the higher temperature. Okay, kinetic energy increases at the higher temperature. See, this is the kinetic energy, this higher temperature, so this energy increases. This peak is here, more energy here, this peak is here, less energy. Okay, question number 28. The graph showing the Maxwell-Boltzmann distribution of energy, the area under the curve must not change. Okay, I already told you the area will not change because the total number of molecules is same. Okay, here this area under this curve and this curve are same because of this total molecules will be same. The area under the curve rises with the increase in temperature. This is under incorrect. Area will not change. Okay. With the increase in temperature, the curve broadens and shifts to the right hand side. This is correct. See what they are saying. See, this curve shifts to the right hand side. See this energy here, this number of molecules lowering, but here it is increasing. Here is the total number of molecules will be same only. That is what is saying right hand side. Which of the following statements are in accordance with the Artis equation? Okay. Rate of the reaction increases with increase in temperature. I already showed you. This is increase in temperature. It will increase because it is 1 by T. So the negative sign will decrease. That will actually rate of the reaction will increase. Rate of the increases with decrease in activation energy. This also I already told you. Mark the incorrect statement. Okay, incorrect. They are also incorrect. Catalyst raises, no, it lowers the activation energy. Okay, catalyst alters, no, it will not change the enthalpy of the reaction. Catalyst lowers the activation energy. This is correct. Catalyst provides the alternate path. That is also correct. Which of the following graphs are correct for the zero order reaction? They are asking. For the zero order reaction, rate is independent of the concentration. For the zero order reaction, see here, see this is independent of the concentration. This concentration power is 0. Okay, that means 1. For any concentration it will be 1 only. The rate equal to K, that is the independent of the concentration. Okay, zero order reaction, so that is why it is constant. And this one, time versus concentration of the reactant. Okay, this is 12. That is also in 12. This one, time versus concentration of the reactant. As the time progresses, the concentration of the reaction will decrease. Which of the following graphs is correct for now first order reaction? Okay, first order reaction 17. Okay, for the zero order reaction, okay, T of, okay, this is for the first order reaction. First order reaction, TF is independent of the concentration of the reactant. Okay, that is independent. So that is what it doesn't change. Reaction TF doesn't change with the concentration. Then time versus the log of this OT for the first order reaction. Time versus log of this, okay, this curve, first order reaction. State the condition under which a biomolecular reaction is kinetically a first order reaction. Okay, 33. Biomolecular reaction become kinetic first order when one of the reactants is in excess. Okay, when one of the reaction is in excess, that concentration change won't get affected. Okay, 33. So here water is excess. So here is 0.01 mole. So it will become 0.1. But if that 0.01 changes, means that change is negligible here because this is in excess. Okay. So now this biomolecular reaction becomes a first order reaction here if one of them is in excess. Write the rate of the reaction for this if the order of the reaction is 0. Order of the reaction is 0 means A power 0, B power 0 only. Power will be 0. Okay, 34. This is 0, 0. So that means anything power 0 is 1. That is rate equal to K only. This will become 1. This will also become 1. See here, when anything power 0, then it is 1, so that rate will become K. How can you determine the rate of this following reaction? That is given when we have to keep one of the concentration same, and we have to increase the other concentration and see the effect of the rate constant. See here, this how they determine the rate of this equation. You see this concentration, they are now doubling this, keeping this constant, and now here they are doubling, keeping the other things constant. Okay, so this is 4 times, this is 2 times, then based on that they determine the rate of this reaction. For which type of reaction order and molecularity have the same value? That is for the element reaction, that is a one step reaction. 36. If the order of an element reaction, the order is same as molecularity. Molecularity and order of a element reaction are same. In a reaction, the concentration of the reactant A is tripled. They are tripling the concentration. The rate of the reaction becomes 27 times. Okay. What is the order of the reaction? Okay, this is 3 power 3 only will become 27. The order will be 3. So the answer. So this 3 times 3, that means that will be 27. Okay, 3, order is 3. Because the concentration of A tripled, 3 power 3 into 3 into 3, that is 27. Derive the expression to calculate the required time required the complete zero order reaction. Okay, zero order reaction. This is for completion, then this will become 0. So that means reactant concentration of the reaction will become 0 on completion. So T equal to, this is the equation 38. So that they took this equation and substituted R equal concentration R equal to 0, then they computed the T. For a reaction, the product, the rate equal to this. Can the reaction be an elementary reaction? The element reaction, molecularity and order should be same. So this is not an elementary reaction. Explain 39. Okay, during the elementary reaction, the number of atoms or ions colliding each other referred as molecularity. At this being an element reaction, the order of the reaction with respect to should have been 1. Okay, because the one molecule of B and reacting, so it should be 1, but here it is 3/2. This indicates the reaction is not an elementary reaction. The order and molecularity should be same for the element reaction. Okay, here molecularity is 2, so this is wrong. For a reaction, large fraction of molecules have energy more than the threshold energy, yet the rate of the reaction is very slow. Why? 40. Apart from the energy consideration, the colliding molecule should also have a proper orientation. I already showed in the book. When it is a proper orientation only, then will be effective collision. This condition might not be getting fulfilled in the reaction. For a zero order reaction, will the molecularity be equal to 0? No, molecularity can never be 0. That means the reaction won't be there with the 0 molecules. 41. The molecularity can never be 0 for a fractional number. Okay, here you see it can be 0, but molecularity cannot be 0 or non-integer. The molecularity cannot be 0 or non-integer. For a general reaction A, the plot of the concentration of A versus time is given here. Okay, answer the following questions on the basis of the graph. What is the order of the reaction? Say zero order reaction, slope minus k. What are the units of the rate constant? That also is given in the book. Okay, 12. So this is for the zero order reaction. Okay, slope is minus k, then unit of the rate constant. Unit of the rate constant of the zero order reaction. Okay, this is the unit. Okay, the reaction between this hydrogen and oxygen is highly feasible, yet allowing the gases to stand at room temperature in the same vessel does not lead to the formation of water. Explain. 43. This is because the activation energy for the reaction is very high at room temperature. The activation energy is very high at the room temperature. Why does the rate of the reaction increase with the rise in temperature? Because of the more collision. I think 44. At higher temperature, larger fraction of the colliding particle can cross this activation energy barrier. That is the activation energy, which leads to the faster rate. Okay, at higher temperature, the more molecules will cross the activation energy, leads to the faster rate. Oxygen is available plenty in air, yet fuels do not burn by themselves at the room temperature. 45. The activation energy of the combustion reactions of the fuels is very high at room temperature. Okay, the activation energy very high at room temperature, therefore they do not burn by themselves. Why is the probability of the reaction with a molecularity higher than 3 very rare? Higher than 3 very rare. The probability is of more than 3 molecules colliding simultaneously is very small. Okay, more than 3 molecules colliding simultaneously is very small. Hence, the probability of the molecularity having 3 is very low. Why does the rate of any reaction generally decreases during the course of the reaction? Because of the lower concentration of the reactant is getting lower. What is the rate of the reaction depends on the concentration of the reactants. As the reaction progresses, the reactants start getting converted into products. So the concentration of the reactant decreases, hence the rate decreases. Thermodynamic feasibility of the reaction alone cannot decide the rate of the reaction. Explain with the help of the example. Okay, 48. Thermodynamically, the conversion of the diamond to graphite is highly feasible, but this reaction is very slow because of the activation energy is very high. The feasibility thermodynamic data indicate the diamond shall convert into graphite, but in reality conversion is so slow that change is not perceptible at all because of the high activation energy. Why is the redox titration of the KMO4 to versus oxalic acid? We heat oxalic acid before 49. The reaction between these oxalic is very slow. By raising the temperature, we can enhance the rate of the reaction. Why can't molecularity of the any reaction is equal to 0? Molecularity can't be 0 because some molecule should be there to react. Molecularity is the number of molecules taking part in the elementary step. For this, we require at least a single molecule, leading to the value of the minimum molecularity of 1. Okay. Why molecularity is applicable only for the elementary reaction, and the order is applicable for the elementary as well as complex reactions. A complex reaction proceeds through the several elementary reactions, several steps actually. The number of molecules involved in each elementary reaction may be different. Okay, the molecular of each step may be different. Therefore, the discussion of the molecular of the overall complex reaction is meaningless because it occurs in several steps. On the other hand, the order of the complex reaction is determined by the slowest step, okay, in the mechanism, and is not meaningless even in the case of the complex reactions. Okay, here complex reactions occurs in many steps, elementary reaction is single step. Okay, 51. So here the order applicable to the elementary as well as complex reaction, whereas the molecularity is applicable only for the elementary reaction. For complex reaction, the molecularity has no meaning because it occurs in the several steps. Why can we not determine the order of the reaction by taking the concentration of the balanced chemical reaction? See, the balanced chemical reaction often leads to the incorrect order of the rate law. For example, the following reaction seems to have the 10th order as per the molecularity. 6 plus 1, 7, 7 plus 3, 10. Okay, this is 10th order as per the reaction seems to be 10th order reaction. Okay, this is actually a second order reaction. Actually, it happens in many steps. Actually, the reaction is a complex and occurs in the several steps. The order of the such a reaction is determined by the slowest step in the reaction mechanism. So the order is determined experimentally and is confined to the dependence of the observed rate of the reactions and the concentration of the reaction. Okay, 52. So this is the explanation they are given. Okay, this reaction which apparently seems to be 10th order but actually a second order reaction because this occurs in several steps. So that means that we are taking into the consideration of the balanced reaction. We cannot determine the order of the reaction by taking the consideration of the balanced chemical reaction. Matching type. This curve rate directly proportional to the concentration. This is A for the first order reaction. Rate is independent of the concentration. This is for the zero order reaction. It's a negative slope, zero order. I already shown you this zero order reaction. There is a negative slope. Okay. This is zero order negative slope. Time versus concentration of the reaction. Time versus the log of this is for the first order 14. Okay, this one okay. This one, this. Catalyst alters the rate of the reaction. C. By lowering the activation energy. Molecularity cannot be a fraction or zero. Molecularity cannot be a fraction or zero. Second half-life of a first order reaction is same as because that is a constant. Okay, half cycle of the first order reaction is a constant. This is a constant. Half cycle it is for the first order reaction. This will be constant. This is independent of the concentration. This refer to the fraction of molecules. This one is referred to the fraction of molecules equal to greater than the activation energy in the Arrhenius equation. Energetically favorable reactants are sometimes slow. Proper orientation is not there always. Area under the Maxwell-Boltzmann curve is constant. So that means that probability total is 1. That is why area under curve is constant. Match the items of the diamond. Diamond ordinarily rate of the conversion is imperceptible, very slow. Okay, that is the instantaneous rate, short interval of time, average rate, long duration of time. Mathematical expression for the rate of the reaction is called rate law. Rate of the reaction for a zero order reaction is equal to rate constant because the concentration reactant concentration power 0 means 1 only. So rate constant is equal to the rate for the zero order. Units of the rate constant for the zero order and the reaction is same as the rate of the reaction. Okay, both in order of a complex reaction is determined by order of the slowest step. I already showed you. Complex reaction, the order is determined by the slowest step. Order of a reaction can be zero or fractional. Order can be zero or fractional. That is correct. Only molecularity cannot be zero or fractional. Order can be zero or fractional. We cannot determine the order from the parent's chemical reaction. This is correct, but this is not related to this assertion. Not related. Okay. Order and molecularity are same. It is incorrect. This is for only for the elementary reaction. So generally this is incorrect. Order is determined experimentally, and a molecularity is sum of the stoichiometric coefficient of the rate determining step. Yes, rate determining elementary step for the elementary reaction and the rate determining step. This is correct. Not correct for the complex reaction. The enthalpy of a reaction remains constant in the presence of the catalyst. Correct. The catalyst does not change the enthalpy of the reaction. Catalyst participation in the reaction forms a different activation complex and lowers down the activation energy, but the difference in energy of the reactant remains constant. Yes, delta H will not change, but it lowers the activation energy. All collision in the reaction molecules led to the product formation. Incorrect. Only the proper collision with proper orientation. Only those collision in which the molecules have the correct orientation and sufficient kinetic energy. This is correct one. Rate constant determined by the Arrhenius equation are largely inaccurate for the simple as well as complex reactions. Okay, correct. The reactant molecules undergo chemical change irrespective of their orientation. This is incorrect. Proper orientation has to be there. All energetically effective collisions do not result in chemical change. Explain with the help of the example. Okay. Okay, you can go through these things. Okay. So there would be a proper orientation, how the chemical proper. All energy effectively do not result in the chemical change. Okay, only with the proper orientation it will happen. See here, this is improper, no product, but proper there is a product. Okay, so you can go through the details how only with certain condition then the products will be formed. What happens to most probable kinetic energy and energy of the activation is rise in temperature. Most probable kinetic energy. This is Boltzmann-Maxwell distribution curve. See, this is the most probable energy level. Okay, here. Okay, this energy level is increased here in this when you increase the temperature, that is shifted to the right side as compared to this lower temperature. Describe how does the enthalpy of the reaction remain unchanged when a catalyst does not change the enthalpy of the reaction. 64. Enthalpy is a state function. Difference in energy between the reactant product is constant. Okay, catalyst does not change the difference in energy between the reactant product. Explain the difference between the instantaneous rate of the reaction and the average rate of the reaction. This is how the average rate of the reaction is computed, with the difference in the rate divided by the time, average rate. Whereas instantaneous rate at this point is computed like this difference divided by this difference, this change divided by this change. Okay, instantaneous rate at 600 seconds. With the help of the example, he explained what is meant by a pseudo first order reaction. One of the reaction is taken at excess rate. Pseudo first order reaction. See, this is pseudo first order reaction. Here water is taken as the excess. So this bimolecular reaction will act as a first order reaction because of this excess. So you will notice that concentration is not changed. Okay, this is pseudo first order reaction. Okay.